track. The person's in motion now. So I'm just going to put the person, let's just say, I don't know, where do you want? You tell me when to stop. Stop. Right there? Okay. That good? That's arbitrary. It's not 120. She's moving, right? She is moving along this track, right? She is in motion. Here, sorry, that was just the direction of the track. I don't want you to confuse that. I'm not telling you she's moving here, all right? So she is in motion, and as she is in motion, the distance between them, that blue line, right, is changing as she moves. So that blue line's in motion. We should probably call it something. Right?
Still creepy. That's creepier.
I have no preference here. I do want to stay away from I like to always avoid lowercase d, because then you have like dd, dt. It's just weird. You know what I'm saying? Like dd, dt. You could do it. It just looks kind of weird to me. You can use a capital D for diameter. All right. I heard S. I like S.
For stalker.
The stalker distance, sure. That's S. All right, we might want to talk about what we are given and what we want here. Do we know any, well, you tell me, I mean. 7 meters per second is the runner's speed, right? Speed is a derivative. Yeah? I agree. What about ds dt?
That's what we want.
That's what you want. You all agree with that? I want to know how fast S is changing with time. So ds dt is what I want. When do I want that? What's 120? S, right? Which is what we're calling S. I want this when S, or at S, you can say either way, when S is 120 meters. Are y'all following this? The only thing I have to resolve really now is what I'm given. The 7 meters per second. I have not incorporated that yet, and I need to incorporate that.
In relation to the radius.
So you shouldn't, this is a natural place to get kind of stuck. Maybe what we should do before we talk about what we're given is actually do something we haven't done in the past, which is try and think about what equation we might use. Because the equation may guide us in terms of what we need to know, like what we need over here. What other letter do we need in order to tie these two together? What are you going to use for this? And you can't look at this, right? You have to look at this one. S. You're going to want an equation that involves S. So let's rule some things out. What can I rule out? It's not going to be a volume, not going to be an area, right?
Yeah.
Pythagorean, I can rule out Pythagorean. And why can I rule out Pythagorean? It's not a right triangle, right? There's only like certain point, there's like 1.2 points in time. When she's straight up, straight down, right? That's it. Other than that, this triangle is not a right triangle. And I'm not even quite sure what triangle you're looking at, but I think I know which one you're looking at. What else? What?
I think it's going to have something to do with circumference.
Circumference?
Something to do with it. I don't know how.
It will, in some sense, have something to do with circumference.
The area of the sector.
Do what? Sector of a circle? Okay, so the sector of a circle has to do with this formula. I'm going to just write it down for you. The sector of a circle, and what, the area or just the, they call it S here? Yeah. S and theta and R, right? That's what they have there. So they give you this S is R theta. That's from pre-cal. It says the measurement of the length of this arc is equal to the radius times the angle. And that angle must be in radians when you use this formula. So what do y'all think about this one? Do you think that this will be useful to us? Is S curved? Is S over there curved? Is this a curved segment? No, it is not. I don't know, maybe if you were looking at the S as being the R, then maybe this S is the curve. It doesn't match up. But this is the thing, you have to start going through the Rolodex of functions to try and figure out what's going to happen, or what you can use. What do you know for sure in this problem is not changing? Her speed's not changing, yes. The radius isn't changing. So I'm going to start writing down some things that I know for sure won't change, and do start to create a geometric picture for me. I know that the distance from the person, the runner, to the center of the track is 50. Always, right? And I'm going to erase this because it's just in my way. Do you agree with that? What other thing do you know for sure? I have it written there. The 100, right? So if I were to just say, okay, look at this side right here. This is 100. Do you see that I've created the triangle? I believe this is the triangle that we were referring to a little while ago, right? But it's not a right triangle. I can do something. That's area. You're thinking area again. All right. I think we're at a point I just have to show you. I'm not, unless someone sees what I'm going to need to do.
Is it something with a trig function?
It's going to be trig, but it's not a trig function because it's not a right triangle. So do y'all remember in pre-cal, you did like trig functions, you know, sine, cosine, tangent,
Oh, I remember this.
and then you moved on, and what did you do after that? You did inverse, okay, and then after that?
Like law of sine.
Law of sines. What was law of sines helpful with? Side angle side, side side side. Remember all that stuff? No, maybe not. Yeah, there was usually an angle in there. And then there was law of cosines also. Law of sines and law of cosines is what you used in pre-cal to help you solve triangles. That's what you used. If we have a right triangle, then we can use the standard trig functions. We can use Pythagorean identity. But if the triangle is not a right triangle, then we have the law of sines and law of cosines. That's how we solve. But here, I still have not incorporated the 7 meters per second. I don't have a second variable right now. Right? I need to get two variables connected. Unless you see something in that triangle that's changing, other than S. The angle, very good. How about this angle right here? Let's just call that angle theta. Is that changing? Yes. Does that change, is the change in that angle related to the speed of the runner? If she's running around this track, her angle is changing, isn't it? And it's changing at a constant rate. Now it's not 7 meters per second, but if she speeds up, the angle goes faster. If she slows down, the angle goes faster, right? Understand that?
Yeah.
Okay.
It's like a clock.
It's like a clock, exactly. So I want ds dt. I want it when s is 120. I'm given something about her speed, but I'd like to see if I can get her speed around the track somehow connected to what? D theta dt. I'm actually going to try and figure out how fast her angle is changing with respect to time. No, this is what I want. This is given to us, just not directly. So this goes back again to pre-cal. And maybe if I say it, you'll go, oh yeah, that rings a bell. Do you remember angular speed?
No.
No?
those things where it was like one problem at the end of the test and it was able to be cut out of y'all's curriculum?
You know,
We didn't have time.
No, it's in the beginning of the semester.
Definitely.
It was,
We did it in Roy's class, but we didn't do it in the second time I took pre-com.
all right, look, we can make angular speed complicated or we can make it easy, all right? I'm trying to make it easy, all right? So let me ask you something here. We're going to step away from this for a second. Let's say I have a track, all right? A round track, that's supposed to be a circle. And let's say that this track, hypothetically, is 49 meters long, right? This is a 49 meter track. That means that you start here and you start running around the track, all the way around the track is 49 meters. I'm not saying the radius is 49, got it? The circumference is what I'm saying. 49 meter track. This, sorry, this girl comes along and she starts running around the track. How long is it going to take her to get around the track? How'd you get that?
That's how fast she's running.
Yeah, but how'd you get 7 seconds?
Divided by 49.
You divided 49 by 7? Do y'all agree with that? So if I take this 49 meters and I divide it by her speed, 7 meters per second, like that, I'm going to look at it like this, and you divide in and, right, you divide the 7 in, or into the 49, you get 7. The meters would cancel, the seconds would flip up, and you get 7 seconds. That's how long it would take her to run around the track, right? She went 49 meters in 7 seconds. Got it? Angular speed is how much of an angle she goes through in that time. So how much of an angle did she go through when she went around the track? She went 2 pi, and we are going to use radians, not degrees. All right? 2 pi, how long did it take her? 7 seconds. So 2 pi, what, radians? I'm put rad for radians. She went through 2 pi radians in 7 seconds. Yes? Now, we're not going to use degrees, but sometimes it's a little easier. Someone on their calculator real quick, do 360 divided by 7.
30 or no.
360 divided by 7? What?
51.4? Okay, degrees per second. Look, if she runs around this whole track in 7 seconds, then she's going to go 360 degrees in 7 seconds, right? Which is 51.4 degrees a second. So she goes, in 1 second, she goes about 54 degrees, 2 seconds, another 51.4 degrees, and then by the end, she gets to 7 seconds, she's gone all the way around. Make sense? That's exactly what this is saying. She's gone the full rotation, 2 pi radians, in 7 seconds. Yeah? This, if I look at this as a speed, which it is, it's the change in what over change in what? Change in an angle over time. Change in angle over time. That's given to us. That demonstration is to show you that if you know how far the track is, right? If you know how long the track is, and you know how fast the person's running, then you can convert that into her angular speed. Once you know her angular speed, you know d theta dt. That's what we're going to do.
Pi r.
Let's do this. So I'm going to start this over. I'm going to try and find d theta dt. So let's go to that circle. What am I going to need to get to start? Radius was given, right? The radius was 50. So what's the circumference of this circle? 2 pi r, right? Which would be 2 pi times 50. So circumference is 100 pi, right? 100 pi. Feet or meters? Meters, right? Meters.
100 pi meters?
100 pi meters. I'm going to leave it as pi. I'm not going to do decimal. Okay, that's how long the track is. How long is it going to take her to go around that track? Divide that by 7. So if I take the 100 pi meters and I divide it by 7 meters per second, then the meters are going to cancel, and I'm just going to get 100 pi over 7 seconds. Understand?
That's d theta dt.
Nope, that's not d theta dt. That's how long it took her to go around the track. Now, how much of an angle did she go through in that time? 2 pi. So what I'm going to do now is say, okay, she went through the entire angle, theta, in that time. 100 pi over 7. She went through that entire angle in radians over this many seconds. And let's clean that up. Can you all clean that up? The full angle. I would rewrite this as, I would write this as 2 pi over 1. And then I'd multiply by the reciprocal.
Get what, 7 over
2 pi over 1 times 7 over 100 pi. And the pi's cancel, and that becomes 50. So 7/50ths? 7 over 50.
Wait, how'd you get, I'm sorry.
No, go ahead.
How'd you get 7 over 50, I'm sorry?
The 2 and the 100. The 2, right? 2 goes into 2 once, 2 goes into that. 50 times?
So it would have just been multiplying straight across and simplifying. Gotcha.
Yes, yeah. When you do division of two fractions, multiplication of the reciprocal, you go straight across. 7 over 50 radians per second is her angular speed. That's d theta dt. 7 over 50. All right. How are we doing here? Oh my gosh, where'd the time go?
It's having so much.
I guess I shouldn't have been talking about parallel lines. All right, we have to finish this up. We're not even there yet. We still have quite a ways to go. We need a formula that relates s and theta together. Law of cosines. I've got to speed this up. Law of cosines. So look on your formula sheet. There's 3 different ones. Are there 3 of them on there?
But
Okay.
we're worried about the longer one, right?
All of the formulas are pretty much the same. If you have any triangle, doesn't matter what it looks like, if we call this angle A, side A, angle B, side B, little b, angle C, side C. So the angle is opposite of its side. Then little a squared will be equal to b squared plus c squared minus 2bc times cosine A. That's in your formula sheet. I want us to look at this in terms of what it is. If you want to know the side, okay, if you want to know the side of a triangle, what do you need to know in order to know this side? Well, you need to know B and C. You need to know 2 of the other sides, right? B and C, and you need to know the angle of the side you're looking for. So look at this. If I want to know what S is, right, I'm going to need to know the 2 other sides and the angle of that side, which is theta, isn't it? So I could use law of cosines to rewrite this to be what?
So s squared.
S squared equals
50 squared
50 squared
plus 100 squared
plus 100 squared minus 2 times 50 times 100, right? Times cosine of theta. And my S's and 5's look pretty close to each other. It's the one letter I've always had trouble with. I don't know why I used S. I don't write in cursive.
You never learned cursive?
I did learn cursive. I can write in cursive, yes, but I just don't write in cursive. Do we have an equation that relates the two letters we want together? Yes, S and theta, there it is. Now a lot of this stuff is constants. So can we go ahead and put all these constants together? Like 50 squared is 2,500. 100 squared is what? 10,000. So 10,000 plus 2,500 is 12,500 minus, that's 100 times 100, it's 100 squared. 10,000 minus 10,000 cosine of theta. Now can I do 1250 minus 10,000? No, because that's attached with multiplication. So this is it. That's it. That's my equation.
That is 5 or an S?
That's an S. Here, let me just put a little thing on the end of it or something. There we go, little S. Differentiate with respect to time. All right, we're going to take derivative with respect to time on the left side. What is the derivative of S squared? 2S times ds dt equals, derivative of this is this constant, right? Just by itself, 0. Constant attached to a function, so it's going to come negative 10,000. Derivative of cosine of something is negative sine. This is multiplication. Negative sine of the something. Done? Times d theta dt. Must take derivative of what's inside the trig function.
That'll be a positive 10.
And that'll become a positive. That'll become a positive 10,000, right? On the right side. Also, there's a 2 on the left. You mind if I just divide the 2 through right now? So we have S times ds dt equals 5,000 cosine, not cosine, sine of theta times d theta dt. There it is. And we look at that and we analyze. Do we know what S is at the moment in time? Yes, 120, right? That was right here. ds dt, do we know that? No, but that's what we want. Do we know what theta is at the moment in time? No. Crap. I'm going to have to find it. D theta dt we do know, right? We do know that. So unfortunately for us, we still need to find theta, don't we? That's the one piece we don't know. But everything else I'm good with. I can't find it. So now I'm allowed to look at the instant in time, aren't I? And at the instant in time, here's what I've got. I've got this, I've got this, I've got this, I've got 120, I've got theta, I've got 50, and I have 100, right? That's what I have at the moment in time. Any way you can find that angle, you find it. So guess what I'm going to use? Law of cosines. I'm going to use the formula I used to come up with this whole thing, right? The relationship between these two sides is law of cosines. So let me put my law of cosines here again. I'm going to just fill out that law of cosines with this information. Instead of s squared, I'm going to put 120 squared equals, now when we plug in 50, 50, and subtract, what did we get on that side before the differentiation? It was 12,250 minus 10,000, right? Cosine of theta, isn't that what we had? That's what we had before we differentiated, except our left side was s squared. So now at this point, let's square 120. So everyone do that, square 120.
14,400.
14,400. Let's subtract 12,500 from both sides. I think I did too many zeros. No. So subtract
1900.
1900, right? So you're going to get 1900 here equals negative 10,000 cosine theta. Divide by negative 10,000. And you get negative 0.19 cosine theta. Y'all okay with that? This is the last problem of this section, which is why it's taking us so long and why it's so complicated. All right. What are we trying to figure out? What's theta? Or we could just figure out what sine theta is, right? Sine theta? We could, right? Or we can figure out what theta is and just plug it in here.
Let's do that.
All right, you took pre-cal for a reason, and one of the reasons you took pre-cal was so you could solve an equation like this. Anyone have any ideas on what you would do?
Well, cosine theta is 1 over sine theta.
No. Hold on. Let me try something. Let me take this back to a fraction for a second.
Cosine theta over 1.
What is, when we were talking about trig functions, cosine, by definition, on a right triangle is what?
Adjacent over.
Adjacent over hypotenuse. Agreed? So look, if I draw a right triangle, my adjacent side needs to be like negative 19. The hypotenuse needs to be 120. Well, you can if you allow yourself to go into the second or third quadrant. So look, instead of going out 19 this way, if I go out 19 this way, and then my hypotenuse is 100, right? This is negative 19? No, that hypotenuse is always positive. 120, where are you getting 120 from?
No, because instead of negative 0.19, you just put it in terms of a fraction.
I just did, this is 19 hundredths. Sorry, maybe I should have pointed that out. This is just, this is this, right? If I would have done this divided by this and just canceled the zeros, that's what I would have had. Yeah or no? Is that okay with you to draw that? But I could have also done it this way. Hey, wait a minute, didn't we say we were going to get two answers? Wouldn't that also draw a triangle that goes out this way and then has a hypotenuse of 100? So if you know that this side is negative 19 and you know that this side is 100, then this side over here wouldn't that give you sine? Because sine is what? Opposite over hypotenuse? So can you tell me what that opposite side is if you know two of the sides? This side right here, let's call it y. You know that negative 19 squared plus y squared, I don't need the parentheses, equals 100 squared, and you can solve for y here? I'm almost out of time and I want to talk about the test. I'm going to square 100. I'm going to square 19. Subtract on both sides. I get y squared equals 639. And then I'm going to take the square root. I get y is approximately 98.1. Nope, y is the length of that side.
Oh, yeah, you're right, sorry.
And then if I want to know what sine of theta is, it's just this side over this side, isn't it? It's just this side over 100. What's this over 100? 0.981? I think I've lost a lot of you. I feel like I have. All right, so I'm going to rewrite this. What is S? 120, right? ds dt is what I want. Equals 5,000. What is sine of theta? We just said what sine of theta was. What was it? It was 0.981. Agreed? Now, one last little thing here. Sine was this side over this side, right? This one over this side. But if I was using this triangle, what would this have been? Negative. So that means, remember we said we're going to get two answers. Here they are. This is plus or minus that number. Two different scenarios. And then the last thing here is d theta dt. D theta dt is, we did this, 7 over 50. And now we solve for ds dt. So I'm just going to do this on my calculator. I'm going to do 5,000 times this, times 7, divided by 50, then divide by 120. See if anyone else gets it. If anyone else gets what I get. Am I the only one doing it? I'm getting 5.72 approximately. Yes, and then it'll turn out to plus or minus, yes. And this is in meters per second. Now I feel good about that answer. Why do I feel good about that answer? It seems realistic. Look, if I'm watching this person run around the track, and she's running at 7 meters per second, what's the fastest she could ever be going away from me? 7 meters per second. But because she's going around the track, she'll never be going that fast away from me. So for this answer to be 5.72 meters per second, I feel good. If that would have come out and it said 15.72 meters per second, I messed up somewhere, right? Now, the positive answer means she was moving away from me at the top of the circle, the top of the track. The negative is she's moving towards me. So the distance is shrinking or stretching out. Exam on Wednesday. Let's talk about it. So here's what you should expect. You need to go make sure you've reviewed your homework, right? You should go through all your homework. There will be problems that'll include all the rules for differentiation, and I'll just want raw derivatives. So kind of like on the quiz. There's going to be power rule in there. That means you have to show me you know how to bring powers down and subtract 1. Remember that problem I gave you on the last quiz? Did I give the quizzes back? If anyone needs any of their stuff, I have it up here. Do you remember the one where I gave you like 3 different things on top, or like it was a couple of things on top and then like one thing on the bottom, and a bunch of you did quotient rule? Just split it up. Be ready for that, okay? Product rule. Okay? Chain rule. Oh, sorry, product rule, quotient rule, chain rule are all going to be, I'm going to give you just a variety of some problems, right? Make sure you understand those concepts. So very similar to that quiz that I gave you. Maybe a few more problems than that. Implicit differentiation, I would expect at least 2 implicit differentiation problems where you actually have to take the derivative and solve for, dy dx or whatever I instruct you to do. So you not only have to do the implicit, but then you have to move things, isolate, divide through, get an answer. I would expect one problem where you have to find y double prime. And that's the one where you had to go through and solve, and it can be messy because you'll wind up seeing in your answer, hey, the original problem is in here, and you replace it with something. And I know we talked about one of those, right? Or yeah, okay. Yeah. So Finding the equation of a tangent line. Don't forget, I mean, that was with the implicit differentiation that I'd given you, wasn't there, we did like Devil's curve. Did we do Devil's curve? Or did we do the cardioid? The cardioid. The cardioid was that problem that looked like this. And we found the equation of the tangent line. So just make sure that you can remember that at the end of it, when you're asked for the equation line, you have to find the slope, and then you have to use the points in the point slope formula. And okay, so be able to do that. And then related rates. So here's what I'm thinking about the related rates. It's going to come to you in one of two ways. And let me get some feedback from you. One way could be I give you 5 problems of related rates with a mixture and variety, but mostly like medium level to hard. Hard being this one, okay? No basic problem. No like a circle's growing. Okay, I don't give you that, but I give you like 5 and I say choose 2. All right? And you can't do all 5 for extra credit. 5, choose 2, that's it. That's one option. Let me tell you the other one. The other option is that I put on the test, I don't know how many related rate problems I'm going to give you, maybe 2 tops. But what I would do is like, let's say it's number 10. What I would do is I would say A, B, and C. And I would give you an A level problem, a B level problem, and a C level problem. And so you would have to choose, I'm going to do the A level problem. This would be a hard one, but let's say this problem is worth 10 points. You could get all 10 points. If you get it right, you get 10 points. If you choose the B level problem, then the highest you could get on it would be an 8.5 out of 10. Make sense? If you chose the C level problem, the highest you could get would be a 7.5 out of 10. But this problem would be basic. Okay. Understand? So that way you can, see, the thing about choosing 2 of 5 is that those problems are going to be a little bit harder, and if you don't get it right, you don't get it right. Here, you can choose to show me, look, I have a basic understanding of what I'm supposed to be doing here, but I'm not going to deserve an A for it. Understand? Yeah. Or you do the A problem and you're like, I'm going to go for it. I feel good about this. And the people who go for the A problems, I usually grade that with that in mind. Like, they are taking the risk here of going after the harder problem, and that to me means something. All right? So y'all like the second one better? Yeah. I'd probably give you like 2 of these. Like here, choose ABC, and then another problem related rate, choose ABC. Y'all like the second method? Yeah. Yeah? Okay, yes?
If we choose 2, are they automatic 10 points?
Yes.
If you get them right.
Yeah.
So if we choose B, get those right, then the most we can make, right, hypothetically would be 9.
Well, no, I'm only talking, these are just for these problems. Let's say you do everything else before this correctly.
Yeah.
Then you could possibly still get an A. It's just for these problems you can't, I won't give you full credit. I won't give you the same number of points as I'm going to give someone next to you who does the A problem and gets it right.
So basically, if you choose a B or a C, you cannot make 800.
No. Well, you can't make 100 on the test overall.
Yeah.
You could still get an A, but not 100.
So the highest you can make it 2 B's is a 97, right? Is that what you're saying?
No. Because again, it depends on how many problems I have before this. Yeah.
Hypothetically, if you had 10.
It just would be impossible to get a perfect score on the test if you choose to do the B or C.
Okay.
That's the best I can tell you right now. I haven't made the test. Any other questions?
You know roughly how many questions will be?
I'm thinking 10, 11 would be tops. Because the first 6 or so are going to be raw derivatives. So I expect those to be quick, 15, 20 minutes tops. Implicit differentiation is probably going to take you in another half hour, you know? And that'll leave you the rest half the time for you to do 2 related rate problems. So you're looking at about 25 minutes a piece on the related rate problems. I mean, that's how much time. That's how much time I want to give you. That's how much time I want to give you. It's all hypothetical.
Implicit differentiation, that's just the dy dx thing.
Yes, but remember with the implicit differentiation, there's a lot of subtleties in there